So in this lesson, we're going to basically be doing the same thing as the last lesson, but we're going to add some additional algebra before because we're going to have trig functions in linear equations. So the questions will say, find all angles 0 to 360 that satisfy the equation below, round to the nearest tenth if necessary. So my first equation is 4 tangent theta minus 11 equals 5 tangent theta minus 4. So the first thing I'm going to do, I'm thinking of this tangent theta kind of like it's an x. In the Delta math videos and in his explanations, he actually substitutes x. When I teach this in the class, I find that sometimes confuses people, so I'm just going to kind of talk about it as x, but leave the tangents. So basically, if I had an equation like 4x minus 11 equals 5x minus 4, that would be an equivalent equation without the tangent theta, and the first thing I would do is move or subtract the 4x from both sides. So in the same way, I'm going to subtract 4 tangent theta from both sides. That's like terms with 5 tangent theta. So that gives me negative 11 equals 1 tangent theta, or just tangent theta in this case, minus 4. Okay, and then my next thing I'm going to do, I'm just going to keep this linear going over here. So right now over here I have negative 11 equals x minus 4. So just like we would add 4 to both sides of the equation over here, I'm going to add 4 to both sides of the equation over here. Now in the linear case, I would be done, right? I have x equals negative 7 as my answer. Here I have tangent theta equals negative 7, but I haven't solved for theta yet. I still need to get rid of the tangent. So to give me room to do the rest of the problem, I'm just going to erase this linear example, but the idea is we're basically doing the same things that you've been doing since, 6th grade with solving, but now we're working with trig. So just this question should look similar to the ones from last lesson. I know I don't have a fraction here. That's okay with tangent. So I see here that tangent is negative, right? So when I think about my ASTC, tangent is negative. It's not positive. So I'm looking for answers in quadrants 2 and 4. So my next step is to do tangent inverse. Remember, we're going to make it a positive 7 just so I can get that reference angle, which will get me one step closer. So tangent inverse of positive 7 is 81.9. So moving those two answers into the second quadrant and the fourth quadrant, or moving that answer into the second and fourth quadrant. For the second quadrant, we have 180 minus 81.9, which is going to give me 98.1. And in the fourth quadrant, we have 360 minus 81.9, which is going to give us 278.9 or 0.1. So those are my two answers. We'll move on to the next problem. So in this problem, for the first time, we're seeing the reciprocal trig functions. In this case, it's secant theta. Basically, everything starts out the same. If I think about secant theta as an x, to solve this equation, we would add 8 and divide by 3. So I'm doing the same thing over here. And then divide by 3. So we get that the secant of theta equals 8/3. Now, I don't have a secant inverse button on my calculator, so I need to remember that secant is the reciprocal of cosine. So if secant theta equals 8/3, then cosine theta equals 3/8. And that's really the only new step when you see a reciprocal trig function. Just before you solve, you want to use the original function and flip the fraction. So from here, cosine is positive. So if I think about those quadrants, Cosine is positive in the first and fourth quadrant. So that's where my answers are going to be. I'm just going to write it over here because I have a little more room over here. So the cosine inverse of 3/8 equals 68.0 degrees. So you can type in 68.0 or 68 there. That's already a first quadrant answer. To get it into the fourth quadrant, I'm going to do 360 minus 68. And so that's going to give me an answer of 292 degrees. So those are my two answers. So in my last example, we see 4 sine theta minus 1 equals 3 sine theta plus 2. And when I think about this, if it was just with an x, I would subtract 3x first, and then I would add 1 to both sides, and I would go from there. So minus 3 sine theta get 1 sine theta, or just sine theta, minus 1 equals 2. Add 1 over, and I get sine theta equals 3. So in this case, sine is positive again. So if I think about my ASTC, I'm expecting answers in the first and second quadrant. So I'll set that up. But when I type sine inverse of 3 in my calculator, I get an error. So maybe I check, am I in the wrong mode? But everything is right. And actually on this problem, there's no solution. And if you think about sine on the unit circle, right, the largest value of sine, the largest y value on the unit circle is 1. Okay, this is also true if we think about the graphs. I'm going to put that over here. I'm kind of running out of new spaces to draw stuff. If I draw the graph of sine, 2 pi, this goes up to 1 and -1, down to -1. If I'm trying to say when does the sine graph equal 3, right, that's never. Okay, so in multiple different ways, basically it's fine for tangent. If you think about the tangent graph and the secant graph and the cosecant graph, they go to positive infinity and negative infinity. But sine and cosine are restricted between -1 and 1, so they can only equal numbers between -1 and 1. Just a thing about cosecant and secant, if you remember, they have that like space in the middle of their graphs, so they actually can't equal values between -1 and 1, but they can equal larger values than 1 or smaller values than -1. Your calculator is going to tell you there's no an error, there's no answer, but that's the reason behind it.